Oh, can you hear now? All right, I've already halfway off the quiz discussion. Anyway, I'll start again. Sorry for that. Yeah, I just accidentally muted myself. Okay, so we will have a discussion about the quiz two. Question one, clause analysis can be used in marketing for all of the purpose below except option A, determine how strongly sales are related to advertising expenditure. B, identify new product opportunity by studying consumer needs. C, segmenting the market based on benefits sought from the purchase of a product. D, selecting markets to test the new products. So the answer to this question is A, determine how strongly sales are related to advertising expenditure. This is can be achieved by using the added budget model, which will be practiced in today's tutorial. It's not a purpose of running a class analysis. So answer A is the correct one. Question two, which of the following is not the value of maintaining a good relationship with customers? Option A, customer will be less price sensitive. Option B, customers will spread a good word of mouth. Option C, we will learn customers better and serve them better. Option D, all of the above are the values of maintaining a good relationship with customers. So obviously A, B, C, they are all correct. They are all the value of maintaining a good relationship with customers. So the answer to this question will be D. Question three, which of the following statement is not a difficulty in implementing first degree price discrimination? Option A, identifying customers' reservation price is difficult. Option B, preventing arbitrage is difficult. Option C, customer may view first degree price discrimination as unfair. D, all of the above are the difficulties. So all the A, B, C, they are all the difficulties in implementing first degree price discrimination. So option D is the correct answer. Question four, your current price of product X is $10 and the corresponding sales are 1,000 units. If you increase your price by um, um, $0.1, that's 1%. Your sales will decrease by 20 units, that's 2%. Based on the definition of price elasticity, what is the absolute value of the price elasticity here? So recall that price elasticity equals to the change of demand, change in the quantity divided by the change of the price. So here, the change of the quantity or the change of the demand is 2%. And the change of the price is 1%. So the price elasticity equals to 2% divided by 1%, which equals to 2. So the answer to this question is D. Question 5, we know Stephen has 80 we know Stephen has 80 chance to be active in 2018 and the yearly retention rate is 90%. What is the likelihood that Stephen will still be active in 2020? So in 2018, Stephen has 80% chance to be active and the yearly retention rate is 90%. So in 2019, the likelihood that Stephen will still be active equals to 80% times 90%, which is 72%. And in 2020, the likelihood that Stevens will still be active will be 72% times 90%, which equals to 64.8%. And the closest number to that is 65%. So the answer to that question is D. And in question 6, in the following GE portfolio matrix, which market segment would you choose to target? So for the GE portfolio matrix, the vertical axis represents the market attractiveness and the horizontal axis represents the competitive strength. So we wanted to have an attractive market and also we want our company to be competitive in that market. So based on these two dimensions, definitely the answer to this question is segment B, because in segment B, the market is quite attractive and also our company has a competitive strength in that market as well. So the answer to question 6 is B. Question 7. You are working on a consulting project for a customer loyalty program like the one in our team project. You believe calculating customer lifetime value will be very helpful for the manager, but you don't have information about the cost to acquire or serve customers. What should you do? So the answer to this question will be B. Even without the cost information, we can still use the CLV approach to calculate the customer lifetime value, which is also useful for the manager to understand the value of the customers. So recall that we have a formula to calculate the CLV, which require us to provide the cost of acquisition and the cost of purchase. But even without these two information, you can still calculate the value of the customer, and that information will still be valuable to the managers to decide who is the valuable customer. So the correct answer to this question is B. And why C is not correct? Try the best to make a good guess about the cost information. So that will actually affect the accuracy of your calculation because you don't know the actual cost. So if you made a guess or you make an estimate of the cost, then the accuracy of the calculation will be actually be affected. Option D, why this is not correct. Use the cost information from a previous consulting project. So each individual company, they may have the different cost structure, and each customer may have the different cost structure as well. So you can't use another company's cost structure to apply to your current company's cost structure. That will cost a lot. That will cause a lot of variation in the calculation of the CLV and also affect the accuracy of calculating the CLV as well. Question 8, think about our team project on a customer loyalty program. Which of the following approach is the best to get an idea of how many clusters may exist in the customers? So recall that in the last tutorial, we talk about the steps in performing a cluster analysis. So firstly, we run a hierarchical cluster analysis to get an idea about the how many clusters are available in the data sets. And then by given the number of the clusters, we run a k-means cluster to determine who belongs to which cluster, and then we use the identified cluster to calculate the demographics within each cluster. So apparently, the question is asking you to get an idea of how many clusters may exist in the customers. So in that case, hierarchical cluster analysis is the correct approach to determine the number of the clusters. And then we compare option A and B. The difference is A is using customers' behavior variable, B is using customer demographic variables. So here, because you wanted to understand that what are the customers' values in each cluster, so it's better to use the customer's behavior variable rather than the demographic variables. The best approach, as we practiced in our tutorial, is like you use the behavior variables to do the cluster analysis, and then for each identified cluster, compare the demographic variables to profile that cluster. So the answer to this question will be A, hierarchical cluster analysis using customer behavior variables. Okay, question 9. 9 to 11 is about using a pricing worksheet in the data file. So question 9, calculate the predicted demand when the price is 12. Which of the following number is the closest to the predicted demand? So let's open up the spreadsheet. So recall the first step we need to do is to get a scatter chart and then add a trend line using the polynomial one and display equation on chart. So when the price is 20, so when the price is 12, the estimated demand will be 0.2031 times x squared minus 12,169 times x and then plus 202.2. So the answer to this question will be option C, 85. Question 10, assuming the unit cost is 6, find out the potential price that maximizes the total profit. Which of the following price is close to the optimal price? So this is about using the solver to find the optimal price that maximizes the profit. So let's first calculate the profit when the price is at 12. So that equals to the unit price minus the unit cost times the demand. Okay, so now we go to data, solver, and we wanted to maximize the profit by changing the value of price. And also we need to set up constraints. The first one is the price should be less than or equal to the maximum price, which is 30. And the second one is, again, the price should be larger than or equals to the minimum price, which is 8. And we'll click solve. So the optimal price is 16.4, which you will have the maximum profit about at 595. So the answer to this question will be option C, 16. If the unit cost can be reduced from 6 to 3, find out how much more profit this company could make. Which of the following numbers is closer to a profit increase? So if the price, so now the price is 5, let's have a record of the current price. So that's at the cost at 6. So if the cost equals to 3, and now we need to solve it again. So now the profit will be 788. So let's calculate the difference. It's 192. And if we go back to the options, the closest one will be C, 190. Okay. Any questions? Good. So let's move to the Edinburgh market response model. So what is the market response model? A market response model describes how the targeting market would respond to different levels of marketing inputs. And if we know the market response to different marketing activities, we can optimize the resource allocation. So think about that you have two markets and you have $1,000 budget for advertising, and you wanted to know how to allocate the resources to achieve the better output, to achieve the best output. Um, so that's the purpose of running a market response model. So this is the formula which commonly used in marketing, which we also call it the ad budget response formula. So here, Y is the predicted output, and X is the actual input. B is the minimum outcome with zero marketing effort. So that means that if you do not input any advertising, what is the organic purchase sales revenue from the market? And A is the maximum outcome. So that means that if you have 1,000 advertising budget and you put all of them into the market, and what is the maximum output that you would expect to come out? And the C and the D are the response parameters. Um, so the response curve shape has two different shapes. It can be a S-shaped when C larger than 1, and it can be a concave shape when C less than 1. So let's do a little bit practice about the ad budget market response model. Okay, so the purpose of this practice is to estimate the parameters C and D based on our current actual inputs and actual output. So these are the input data, and we wanted to use that input data to estimate the parameters C and D. And once we got all the A, B, C, D, we can use this model to predict all the modeled output using this formula. Okay, so let's first set up A. So A is the maximum outcome. So that equals to, in the actual data set, that equals to 60. The B is the minimum, and that's in the original data, in the actual data, it's 5. And then we will leave C and D blank because we wanted to make an estimate of them. Now let's using the formula to put the modeled or the estimated output based on the input. So let's say, so when the input is 0, the output is $5, and the actual output is $5, and the estimated or the modeled output equals to the minimum output from this formula, which is $5. That's B6. Sorry, that's C6. And when it's maximum, when the input is maximum, the actual output is $60, and the modeled output will also equals to the parameter A, which is C5. And in between, when the input is $10, the actual output is $25. And we wanted to use the formula to calculate the modeled output. So that equals to B plus A minus B times X, the power C of X, divided by D plus the power C of X again. So we can drag it down to make the Excel calculate the modeled output when the input is 15. Now, because we don't have any value in C and D, that's why they all equals to 60. So that's fine. That's okay. We wanted to let Excel to optimize the C and D and to make the actual output. So let's first calculate the error. That equals to the actual output minus the model output and squared. And the total sum of error, that equals to now we want to use the solver to let Excel estimate the parameter C and D and to minimize the total squared error. That means that if we can get a number of C and D which minimize the total squared error, that is something we can say that our model exactly predicts the actual output, right? So let's go to data, solver. So we wanted to set objective. We wanted to minimize the total squared error by changing C and D. And I will click solve. Okay, so Excel calculates that parameter C equals to 0.93, parameter D equals to 14.91. And in that case, our actual output match with the modeled output, which means our model exactly predicts the actual output. The error equals to 0. Okay, so now we have all the A, B, C, D. We can use that formula to calculate all the, we can use that formula to calculate the output for any level of the input. So let's say when the input is 20, so that equals to B plus A minus B times X. So X here is B25 power C divided by D plus B25 power C again. So our model predicts that when the input is 20, the output as predicted will be 33.67. Even though we don't have the actual output for the 20, but because our model was performed quite well in its accuracy, so we can assume that when the price is 20, when the input is $20, the output will be around 33.67 as predicted by the model. And let's try the different input levels as well. Okay, we can just copy and paste here, and we'll drag it down. So when you find out that when you increase the input, it's not a linear relationship with the output. It's kind of like a concave relationship. Always say it has a diminishing return of the investment. That means that when you reach some certain point, even if you wanted to increase your input, but you won't get a same unit of the incremental output than before. So this is how we use the ad budget model for advertising to predict the output using the different level of the input. Let's quickly do the market B as well. A equals to the maximum, C18. B equals to the minimum, that's C15. We'll leave C and D blank for Excel to solve. And the minimum is 10, is parameter B, maximum is parameter A. And for the rest, we use the formula plus A minus B times X power of C divided by D plus X power of C. And then we calculate the error squared, that equals to the actual output minus the modeled output, and then squared. And the total squared error, that equals to the sum of all the individual error. Okay, and then we click solver. So this time we're gonna minimize the total squared error, and by changing the parameter C and D. Click solve. Okay, so now for market B, Excel calculates that the C is 3.97, D is 46387, and in that case, our model will fit the actual data points. And we got the error squared equals to 0.0001, which is very, very accurate in terms of the prediction. Okay, so the model is good. And when the input is 20 for market B, the output will be 32.74. And we can draw the curve as well. So you can see that here's an S curve. Initially, when you put a bit extra input, that won't generate a lot of the output. But beyond a certain point, when you put a unit input, it will generate more output. But then beyond a certain point, when you put an extra unit of input, it will have a diminishing return of the investment. So it's an S-curved. So recall that when we say when C larger than 1, it's an S-curved shaped response model. And when C less than 1, it's a concave response model. Okay. So I think it's quite straightforward and clear. So what I'm going to do is I'm going to give you 10 minutes. So you can conduct the same analysis for market A and market B. And also, if you want, you can discuss with the classmates about the difference between market A and market B. All right, so we'll have 10 minutes for you to practice a bit more about this added budget model. If you have any questions, you can ask me. I got a question asking, how does this relate to advertising log if you were to translate the numbers to words? Can you be more specific? I'm not quite get it. Like the numbers that you got at the end to form the graph. So this is not about advertising itself. It's about budgeting. It's about how you allocate the budgets in advertising to achieve better outcome. So suppose that you have two different products and you have 1,000 budgets in advertising for each for total. And you need to allocate your resources, right? Maybe you want 500 for product A and 500 for product B, or you want a 600 for product A and 400 for product B. But by using this advertising budget model, you will get a predicted or the modeled optimize the point of allocating your resources. And we will go through that in our next practices, which is about resource allocation. Does it answer your question? Good. Okay, let's continue. So, um, resource allocation. So suppose that we have a budget of 25,000 for advertising. How to allocate the resources to maximize profit for market A and market B. So this is what I said before. So we have a set budget and we have two markets and you wanted to allocate the resources which maximize the profit uh, for your company, which means that you have the maximum profit for market A and the market B. So how can we do that? So it's easy. Let's go back to the add a budget exercise spreadsheet under the third tab, optimization 25K. So we have market A size 900,000, market B 800,000. Input level initially we set up an initial value at the $10 for each, and the output, or in other words, if we spend the $10 for advertising for 1,000 customer, then what is the output? So we can use the previous identified added budget model to make the prediction about the output. So that equals to B plus A minus B times the input X C power of C divided by D plus the input X and power of C again. Okay, so it's quite straightforward. So you just use the previous identified added budget model for market A to predict the output by using the given input, which is $10 in our example. And also we do that for market B. Market B, B plus A minus B times the X, the power C of X divided by D plus power C of X again. Let's do it again. Okay, that's all right. That's good. Okay, so as predicted, when the input is 10 for market A, the output will be 25, and for market B will be 15. The advertising cost equals to the unit cost times the market size. So that equals to $10 times for market A equals to $10 times 900,000 And we also needed to divide it by 1,000 because here it says that the advertising dollar is for 1,000 person per year. So to calculate the correct advertising cost, we needed to divide the sum product by 1,000. Okay, and we can copy and paste here. And sales revenue equals to the size equals to times the output, and also divided by 1,000 as well, because it says that the output is also the sales dollar for 1,000 persons per year. Copy and paste here. Profit equals to the sales minus the cost. And we calculate the total for each. Okay, so we haven't yet using the solver to optimize the price, but now when the input is 10 for each, we can see that our advertising cost will be 70,000. Our profit will also be 70,500. Okay, so we because we have a budget of 25,000, so this is definitely under our budget. We wanted to use our budget as many as possible, and we also wanted to maximize the profit. So I guess most of you have already know how can we do that. So we go to solver. This time, this objective will be the profit, and we want to maximize the profit, and by changing the input. And we also need to set up a constant because our budget is 25,000. We need to make sure our total advertising cost will not exceed 25,000. So we add F8, that's the advertising cost, the total advertising cost, smaller than or equals to 25,000. We'll click OK, and click solve. So Excel solved this issue for us. So to maximize the profit for your company, as predicted, the input for market A will be $10 and the input for market B will be $19. And under this kind of scenario, you will use all of your planned budget and you will get the maximized profit, which equals to 23,000. So that is how so by doing this, you will know that under a given budget, how you allocate your advertising resources or your advertising expenditures to maximize your sales revenue or sales profit. So some people may ask that if we don't have a budget, if we have unlimited resources we can spend, what is the possible kind of like scenario that we'll get? So let's do another scenario testing. So this time, we don't have a budget constraint. We don't set up any budget. We do the solver again, and this time we don't have any budget. So we just wanted to manipulate the input and to maximize the profit. So if we don't have any budget, the maximum profit that we get is 23,903. And if we compare with the previous one, let's copy and paste here. Okay, so this is without budget, and this is with budget. if you compare this two, you'll find it out if you don't have any advertising budget, you needed to spend 2,600 extra to get only 195 extra profit, which is unreasonable, right? No one is gonna spend that 2,000 extra to get just an extra of 100 something profit. So it probably shows that in a marketing practice, it's a good idea to set up a budget for any kind of expenditures. If you don't have a budget, it doesn't mean that you will get unlimited outcome from spending, because every penny you spend will get diminishing return when you beyond a certain point. So it is really important to set up a budget to avoid wasting resources. Okay, so before we move to the next section, which is the probability model for PPC, I like to have 5 minutes break. You can stretch your legs, have a cup of tea, and then we'll come back in 5 minutes. Okay, welcome back. So the next section is the probability model for pay-per-click analysis. So let's firstly revise some key terms we've learned during the lecture. Impressions is when an ad is fetched from its source. Clicks is the number of the clicks. Cost per click is the amount that the advertiser pays for each click. The conversion is the number of the purchase followed by the click, and the conversion rate equals to the number of purchase divided by the number of the clicks. So we firstly calculate a probability model for PPC. Let's go to the spreadsheet. This is actually quite simple. So the cost per click is 0.5. The click per day is 50. The conversion rate is 8%. The profit per sale is $10, and the days per month is 30 days. So firstly, we need to calculate the conversions per month. That equals to clicks per day times the conversion rate and also times the days per month. Okay. So the conversion rate and so the clicks per day is 50 times 8%. That is the conversion each day. And we wanted to have the conversion per month. So we have to times the days per month as well. Sorry. um, okay, so let's do it again. Can you guys see it right now? Yeah. Okay, yeah. So the key terms include the impressions, the clicks, the cost per click, conversion, and the conversion rate. And to calculate the conversion, so we go to the first spreadsheet, and if we want to calculate the conversion per month, that equals to the clicks per day times the conversion rate, and that gives you the conversion per day, and then we times the days per month, and that got you the conversion per month. Sales profit, that equals to the profit per sale times the conversion per month. That's the sales profit per sale times the number of the sales. So it's the sales profit. So that's the profit per sale times the conversions per month. And the click costs, that equals to the cost per click times the clicks per day and also times the days per month. So that gives you the cost per month that the advertiser needs to pay to the company company for advertising online. And the profit after advertising cost will be the sales minus the cost. So it's 450. So the conversion rate is really important in online advertising. If you have a really low conversion rate, that probably means that you will get lower or even negative profit after the advertising cost. But if you have a high conversion rate, then you will definitely have a high profit after the advertising cost. So let's do a scenario test to see how the conversion rate will actually affect the profits after the advertising cost. So we can go to the developer ribbon. And if you don't have the developer tab here, you can just go to File, Options, Customize ribbon, and tick that one. That's one the developer one was by default is unticked. So you need to tick that one. Okay. And then click OK, you will get the develop tab here. And we choose insert form controls, and we select the scroll bar. And once you draw the scroll bar, right click, format control, link a cell link. We link to H5. Let's make a random link here. It doesn't matter. And we'll set the current value at 80. And the conversion rate equals to H5 divided by 1,000. Okay. So now if we drag this scroll bar, we can see that the conversion rate is changing, right? So when the conversion rate is 4%, the profit after cost is negative, which means that your company is losing money to advertising online because you have a low conversion rate. So you need either to improve your conversion rate by improve the quality of the online advertising, or don't do the online advertising again because it's worthless. It's causing you losing money. And as the conversion rate increases to 5%, we will see that the profit after advertising cost is 0, which means that you are neither losing money nor making money by putting this advertising online. So this is the break-even point. So if you can't achieve 5% conversion rate, which means that you're definitely going to lose money from putting advertising online, which you should either improve your quality of advertising, attract more people to buy the products, or don't waste your money on this online advertising. And if we increase a bit, you will see that you're making profit after the advertising cost. And if your conversion rate is high enough, 10%, you're getting more profit than the conversion rate is at 8. Okay, so the profit of advertising cost is quite sensitive to the conversion rate. And for an online advertising, you need to determine using some calculations to determine what is the break-even point of your conversion rate, and monitor your conversion rate. If the conversion rate is below the predicted break-even point, then it's not necessary. It's not necessary to advertise it online. You should either improve the quality to improve the conversion rate, or don't waste your money to do the advertising online. Okay, so let's move to the next one. So the next one is about the generalized second price auction. So basically speaking, this is the formula. So this is the formula which determines the price of the bidder that the bidder needs to pay to the advertising platform, such as Google, about the cost per click they need to pay. So Google uses a very complicated approach, which is called the second price auction, which means that the price the bidder pays equals to the the next bidder's price times the quality of the next bidder's advertisement divided by the quality of your company's advertisement. It's a little bit complicated, and you don't need to understand why this is like that. But for your interest, there's some kind of like explanation about why Google and other online advertising platform or agency they adopt this second uh, second auction price model. Um, so let's just go straight to the practice. We're gonna practice about this second generalize the second price auction model. We'll go to example 3. So firstly, we need to calculate the bid times quality. So that equals to the bid times the quality. We copy these initial data from B33 to E36 into the next table. And we needed to sort based on the bid times quality from the largest to the smallest. So after sorting, you will find out the bidder 2 has the highest bidder times quality, followed by bidder 3, 1, and 4. So bidder 2 will win this advertising slot. So we put 1 here. Bidder 2 is in the first position to win the advertising slot, and bidder 3 will be the second, and bidder 1 will be the third, and bidder 4 will be no way. And for the PPC, recall that the cost per click for that bidder equals to the bid times quality of the next bidder divided by the quality of that bidder's advertisement. So that equals to E40. So that's the bidder times quality for the next bidder, for the bidder in the next position, divided by the quality of your advertisement. So that's D39. And we copy and paste into the other two. So apparently, bidder 2 will pay 2.67, which win the first slot in the online advertisement. Bidder 3 will pay 3.75, and bidder 1 will pay 4. Okay, so this is how we calculate the bidding price for in a competitive setting by using the generalized second price model. Okay, moving to the next, incremental cost per click. So the incremental cost per click that equals to the cost of incremental clicks divided by the number of the incremental clicks. So there's some rule of thumb. If the value per click less than ICC or the incremental cost per click, you needed to lower the bid. If the value per click larger than RCC, you need to increase the bid. So let's go to the practice. In tab 3, ICC in auction, the profit per sale is $100. Conversion rate is 5%. The value per click is $5. And firstly, you need to calculate the profit from sales. So that equals to number of the clicks times the conversion rate. So that's how many people have actually purchased the product after they click your advertisement, right? And also times the profit per sale. That's the unit sale. Drag it down, and then you will get the profit for the different scenario. And also you need to calculate the click costs. So that equals to the number of the clicks times the cost per click. And then we drag it down to get all the click costs for the different scenario of bidding price. Profit equals to the profit minus the click costs. Okay. So now we need to calculate the ICC. So recall ICC equals to the incremental change in costs divided by the incremental change in the clicks, right? So let's go back to the slides. It's the cost of incremental clicks or the incremental change of costs divided by the number of the incremental clicks or the incremental change of the number of clicks. So that equals to, first, the incremental change of the costs F7 minus F8. So that's the incremental change of the click costs divided by C7 minus C8. That's the incremental change of the clicks, the number of the clicks. And we drag it down. And by doing this, you will calculate the incremental cost per click, ICC. Now recall our rule of thumb. If the value per click less than ICC, we're going to lower the bid. If the value per click larger than ICC, we need to increase the bid. So here, the value per click is $5. And in which scenario, in which bidding scenario that we can maximize our profit? So it's here, right? When the ICC is 4.63, which is the closest to the value per click, $5, we can maximize our profit. So as a marketing manager, after analyzing this bidding scenarios, you will know that you need to bid for $4 for the advertising slot. And once you're bidding for the $4 advertising slot, you can maximize the profit. That's the purpose of conducting the incremental cost click analysis. Okay, so I'll leave you guys about another 10 minutes to practice by your own regarding this PPC calculation. And if you have any questions, you can ask me. Okay.
Hi, Tony. Are we able to start the consultation after everyone's done, the consultation hour?
Yes. Yeah. So you. Yeah. So I will start the consultation after this tutorial. So you needed to join my consultation Zoom meeting. Okay. Any questions? All right, so if you don't have any questions, that's the end of the tutorial. We are ending it early than we planned. So I will start my consultation once we finish the tutorial in 5 minutes. Um, and for anyone who don't have a record of my consultation Zoom meeting link, just follow the link in the chat, and then you will get into the consultation meeting room. So that's everything, guys. Next week we'll have the presentation from each group regarding the project. So be prepared. Each group will have maximum 15 minutes. All right. So thank you guys for attending. See you guys next week.